Fine. The schemas that we have are star schema and Snowflake star schema. So what is star schema? A fact table like sales surrounded by different dimension tables. Like this is my customer dimension table. Okay, this is my product dimension table. This is my employee dimension table. Okay, so I have different. Okay, I have different dimension tables which are surrounded around this particular fact table. Okay, so this kind of arrangement is nothing but called as a star schema. Now you don't see this particular diagrammatical representation within any of your databases, but it's a logical representation. So when I say logical representation, what it means is, like, if at all there is a table created, the tables within your warehouse database are logically linked to each other, right? So what do I mean by logical representation? The cust ID, right, is a primary key here, which will be seen as a foreign key in some other table, right, which will be seen as your foreign key in sales table, right? So this is nothing but my logical relation between these two tables. All right, likewise for sales table you have another column as a primary key called as your product ID. All right, the product table you have a column called as your prod ID, which is as my primary, right, which is as my primary one. Okay, so again this is a logical representation. Again I have another column, and what is this particular column? Let's say employee ID. This is my foreign key. Okay, so which is again related to another table called as employee, which is as my primary key. So this is the logical representation that you would be having within your database. Okay, and this kind of representation, this kind of linking is nothing but you're called as your star schema. A fact table surrounded by different dimension tables is nothing but our star schema. Okay, clear? Now you have another schema called as your Snowflake star schema. So this Snowflake star schema is derived from the star schema. It's an extension of your star schema. And what do you have additional in Snowflake star schema is you will be having references to these particular dimension tables. Right. Earlier we don't have any references. Now what you see in case of your Snowflake star schema, you would see a particular reference tables that are getting attached to this particular customer table or any of your dimension tables. Now this kind of arrangement is nothing but called as your Snowflake star schema. So what happens here? Here you have your customer table. This may be having a relationship with another dimension table. So such dimension tables are called as your master dimension tables. This may have another relationship with another dimension table, master dimension table. So this kind of representation is nothing but your Snowflake star schema. Okay, so what is a star schema? A star schema is nothing but a fact table surrounded by different dimension tables. Right. What is a Snowflake star schema? A fact table surrounded by different dimension tables, and these dimension tables has references to the master dimension table. Okay, this is what a Snowflake star schema is all about. Now these are just concepts, you need to have an understanding on it. Okay, it is more of a data modeler activity to know how to establish a relationship between the tables and everything. But we as a test engineers, we need to have an idea about these schemas, these concepts. Okay, fine. So these are the two different schemas that I have. Now within the data warehouse, there are classifications of dimension tables. You have the tables classified into dimension tables, mainly classified into slowly changing dimension tables. Alright, confirmed dimension tables, junk dimension tables, and date and time dimension tables. Alright, so again this slowly changing dimension tables are classified into SCD1 or type 1 tables, SCD2 or type 2 tables.
What do you mean by master dimension table here? Like I
Okay,
understood the dimension table has that master information about the tables which are related to the fact table, right? But what does master dimension table have it?
okay. I'll give you the schema identification as well. Cust ID, cust name, city, state, country. Let's say I have these columns in my dimension table, the customer table. Okay, customer is my dimension table. Perfect.
Right, yeah, correct.
Right. Now I'm maintaining the data in this way within my table. Duka, Hyderabad, TG, India. And so on. If I have the data in this way, now you see there are certain columns for which the data is always getting repeated. If I have, let's say, if I have the table, this customer table, which is having 10,000 customers for Hyderabad, 15,000 customers for Bangalore, 12,000 for Chennai, 10,000 for Mumbai, and 25,000 for Delhi. So what happens? You see these particular columns data getting repeated, and for all these columns you see the country column getting the data repeated. Likewise your state repeats for 10,000, 12,000, 15, 10,000 and 25,000, and the city name is also the same way. So what they do in order to make a better performance of your warehouse, what we do is we split this particular table into two. Okay, so what happens here? Okay, let me write that. What am I trying to do here? I say cust ID, this will be remaining as it is, cust name, okay, then location underscore ID, and parallelly what would I do? I would create another table which would be holding my master set of information, master set of my dimensional information called as location, and which would have the columns as location ID, city, state, country. Now here within the location ID, I'm giving the values as let's say 110, 110. This city is Hyderabad. Alright, state is TG. Right, country is India. Likewise, 1111. This would be my Bangalore, right? KA Karnataka, India. Another one, 1112, right? Mumbai, right? Maharashtra, India, and so on. I'm just creating that. So what happens here? For all these particular records, I need not to maintain these three columns again in my dimension table. So what am I trying to do? I am trying to split my dimension table based on the location ID. So what will happen here for this all these particular records? If I say all these particular records, I will not maintain Hyderabad TG and what do you say India. The value would be 1110. Right, this would be the same value that I would be maintaining for all the Hyderabad records. Now, where is my information stored here? Now,
Location and dimension table.
right. Now I have passed a location ID. Now where is this particular location ID coming from? This is coming from the location. So what is happening here? Okay, this is my sales table. Assume that, and this is my customer table. Now customer table has got a reference to the another dimension table which is called as my master dimension table. This is my customer which has references to the master dimension table where it picks the references of this particular location. Is that clear? So the table which is going to carry this. So here we need not to repeat the Hyderabad related data for 10,000 times or Bangalore related data for 15,000 times or Mumbai related data for 12,000 times. Right? We just create a location table once and that would have any number of cities that we have in our India, in our country, and that would be mapped to this particular customer table. As simple as that. Is that clear?
Got it. Yeah. Thank you.
Yeah, thanks. Okay. All right. So I have these as my classifications of my dimension tables. I have the dimension table classified into slowly changing dimension tables. The slowly changing dimension tables are again further classified into three types: SCD1, SCD2, and SCD3. So what is SCD1 here? Please pay a bit more attention on understanding these three tables. These are very important tables and you would be asked in the interviews. Okay, so I'll stretch some more time to give you more information about these tables. Now SCD1 table, the rule for SCD1 says that inserts are inserts, updates are updates. This is what the rule says. So I'm expanding this particular rule now in a bit more understandable way. Inserts happening at the source should be seen as inserts in the target. Updates right, let me complete. Should be seen as updates in the target. All right, so before I proceed, let's take uh, yeah, I understand. And this is my target table. Okay, and I have the records in this way in the source. I'll always pick employee table because that's the easiest table to understand the things. Okay, so EMP ID, E name, job, salary. These are the four columns that I have in my source, and in my target I have SG underscore EMP. So what is SG underscore EMP here? SG underscore EMP is nothing but my primary key, which is nothing but a called as a surrogate key in our target table. And likewise, I have EMP ID, E name, job, salary, record insert date. I mean when the record got inserted. Record updated date, when the record got updated. So these are the columns that I have in my target table. So I'm naming this particular table as EMP. I'm naming this particular table as EMP underscore SCD1 or type 1. Slowly changing dimension table 1. Here EMP ID is my primary key. Okay, let me. EMP ID is my primary key. E-name, job, salary. Alright, now let's have this particular data here. 1001 Durga, right? QA lead. Alright, salary is as 5,000. Likewise 1002 Satish, okay, QA engineer, and 2,500. This is my data. Now, in order to move the data from this particular source table to your target table, we need a workflow or we need a particular job that needs to be configured. And I'm terming this as my job. Alright. When I execute this particular job, what the job should do? Job should pick this particular data. So what this particular job has to do? This particular job has to pick this particular data and load into my target table. Before doing that, okay, I have some audio connection problem here. Just give me a minute. Yeah, sorry guys, there was an audio connection problem. Okay, now what am I supposed to do? Yes, it is the job has to pick the incoming data and it has to move or load into my target table. Now the job responsibility is to do two things. It has to check these particular incoming records, whether the incoming records are new or updated. Whether the incoming records are new or updated or same, no change records. It has to figure out these three criteria. Okay, now let's see. Now, how will it classify that the records are new? If the records are new, then you will not see those instances in case of your target table. Now, looking at these two records, what I can say, are they new or updated or same records? What I can classify these records as? Come on. What kind of records are these?
New record.
Perfect. These are my new records. Now look at our thing, our rule. Inserts are inserts. So when I can
Durga,
say
please,
that a
please, please, please. Can you
sorry,
repeat, please, please? I don't understand. So that new updated another one. That's the I can't answer. So could you
okay,
please
no problem,
please, yeah.
not an issue. Right now, what is the rule says? The rule says that inserts are inserts. So that means, how can I say record is getting inserted? Whenever it is a fresh set of data that is getting loaded, you can say inserted. Now you see this is a new set of data, then I can say that these are my inserted records in my source, and I don't see these particular records, so they are classified as new. So what the job supposed to do, as in when I execute this particular job, what happens? The job has to load these particular records into my target table. See, I'm loading the records. Now I'm classifying the data here. I'm giving the surrogate ID value as 11101. Okay, I'm just giving it. Alright. Employee ID, the value is 1001. And who is that? It is Durga. And who is that particular, what is that particular job? His job is QA lead 5,000. Now I'm trying to say that we are starting this particular job on 1st of July. Okay, so record insert date is 01/07/2015. Now this is a new set of record, right? And it's not an updated, so your record updated date value will be as null, right? Likewise 11102, yeah, this is 1002, this is for Satish, yeah, he is the QA engineer, right? His salary is as 2500, right? He also loaded, I mean his data is also loaded on 2015 July 1st. Null. Now what happened here? I have two records at the source and they were new insertions happening at the source, and so they got inserted in my target. I'm meeting this particular criteria. Inserts are inserts. Inserts happening at the source should be seen as inserts in the target. So how did I classify that the incoming records are new records? Because I don't see their instances in my target table. Based on that, I could classify them as my new records. Okay, done. Now this is done. In a course of time, what happened? I got another set of data. Alright, I got another set of data in the source. The other set of data is 1003. Mr. Kumar, he is as project manager. His salary is 7,500. Now, when I execute this particular job, what would job say? What would job say about the incoming record? What kind of a record is this?
New record.
New record. Right. Again, what should happen in loading the data? It has to insert it. Right. So 11103 1003 Kumar, right? So he is as PM, okay, 7,500, and let's say he was loaded on 2nd of July, and now. So every time a new insertion happening at the source will be seen as insertion in your target. Now the second case. Alright, let's say in a 10 days time, we have the record of Durga got updated. Right, he is still a QA lead, but his salary has been changed, 5,500. Now what the job has to say now? Do I have any instances of Durga in my target table?
No.
I have the instances of Durga in my target table. It would classify based on this particular column called as EMP ID. Do I have the same employee ID in my target table? Yes, I have the same employee ID. I see this 1001 appearing in my EMP underscore SCD1. Now, when it finds a match, then what it does, it checks the data that is seen in all the columns. Okay, 1001, oh, no problem. Nothing is changed. Name will never change. Perfect. Job, okay, no change in job. But salary, yes, there is a change in salary. So that means what has happened? Update happened, right? An update has happened at the source. Okay, so this is classified as an updated record. Let's say this has happened on 10th of July. Okay, so it has figured out that this is an updated record. As a result, what the job supposed to do? The job supposed to update this particular table, right? Job supposed to update your target table stating that it is 5,500. Okay, let me do it. Sorry, I should have enlarged this.
So it should be as a new record with new that ID, right?
Sorry.
Exactly, the Durga. This the updated should be in the new record as in the target table, not the
Yeah,
what the old should
exactly.
not be a old record. What I mean.
New record. I'm not getting your question properly. I'm sorry.
No, no, no. In the target table, you are modifying the existing one, right, Durga?
Yes,
So, but as per what explained, so it should be as a new record, right, with a new
I'll
ID.
come to that point. I'll come to that
Okay,
point. Okay, why it is
okay,
happening as so, and why it is not coming as a new record. The rule for
okay.
SCD1 says that it has to update the existing record only. But why is it so? If so, why we have given the definition as in that way?
Got it.
Right. Fine. I'll talk about that one as well because that is as part of my explanation as well. Okay.
Sure. Okay.
So let me complete this. Then I'll talk about that particular point as well. Perfect. Good catch, man. All right. So 5500 it has updated the existing record and your null value will also get updated. So what it says, because it's nowhere in null now, you see a data getting updated and this was updated on 10th of July. Okay. Now what is happening? The rule of SCD1 says in this way, what it says, it is saying that inserts happening at the source should be seen as inserts in the target, updates happening at the source should be seen as updates in the target. So indirectly, what kind of a data that we are maintaining in the target table? The data that we maintain in the target is same as our source table, right? There is no change in the data or source structure. Okay, we are maintaining the same data as it is, or indirectly I can say I am always maintaining current data, isn't it? Do I see any history information of Durga here? I don't see that particular information. Now why is this so? I was talking about a data warehouse and I was figuring it out, or I gave a definition that it maintains current and historical data. But what is this? This particular table is maintaining only current data. So why is this particular contradictory? Now, these tables are implemented for two set of reasons. The first reason is, in a business, we may have to operate a particular business. Your business may have around 100 set of tables or what is it, 50 or 100, whatever may be the count. But all the tables will not be coming for your analysis purpose. All the tables are not required for your analysis purpose. Only few tables are treated, or few tables for your business related data are treated for the analysis purpose, and such tables are taken as part of your historical data, or such part of the tables are taken for the maintenance of your historical data. But the other set of tables, if we create them with a bigger size, we will be losing the memory of the database, right? So such tables which are at least what is useful in helping the current data for the analysis, in such cases you would be going with the implementation of SCD1 type. And the second situation where you see SCD1 types is mostly in your migration projects. Let's say ICICI Bank, alright, earlier maintaining their data in Oracle, now they wanted to migrate it to SQL Server. Okay, what they are supposed to do? Yes, they have their all set of data in their old tables. Like let's say the tables are your any customer related tables or payments related tables, whatever it is. All right, they have their tables in this way. Now they're just migrating the data from Oracle system to your SQL Server system. So in that case, what do? They'll just bring the data as it is. They will never make the historical information in that. movement of that particular data. So they'll just bring the data as it is. So in such cases also, the tables will be classified as SCD1, or the tables will be, what do you say, uh, the tables will be designed in SCD1 manner. Okay, so this table, the purpose of going with the SCD1 type is, wherever, or you'll create these SCD1 tables where you do not need the historical data for your analysis. You are good with the analysis with the current set of data. When you have such a requirement, then you would go with the SCD1 type implementation. The second other reason is, not all tables within a particular operational system will be useful for your analysis. Only few tables are useful for your analysis purpose. In such a case, the other tables whichever are not useful for your analysis purpose, the historical data analysis purpose, what we do, we pull the data as it is into our warehousing tables. Okay, that is the reason for maintenance of this SCD1 type. Now you would see the data warehouse definition correctly implied on this particular type of table, SCD2. Now in this table what it says, inserts are inserts and updates are inserts.
Durga, sorry to
Yes,
interrupt you.
please.
This is type 1 we are talking. So we are saying there's no update. So what is the purpose of just storing in the data warehouse? If we are not doing any update, we are not doing this, just kind of the whatever data we are just having in the source, we are just moving to the target one. So what is
Okay,
the purpose of that?
I got your question. I'm giving you the answer. Let's say this is my source, okay?
Yes.
And I have around 100 sets of tables. And this is my target, let's say. Here, from the source, not all tables are useful for my analysis. Only few tables are useful for my historical analysis purpose, but rest all are good with the current set of data. Okay, so if I just move only those tables which will maintain historical data into my warehouse, can I alone analyze the data with these particular tables? There can be a dependency of these tables on the standalone tables or my current set of tables, right? So what is my necessity now? Even I have to bring those tables into my warehouse. All right, though they are not maintaining my historical data, right, but they have certain relationship between my historical tables as well as my current tables. So what am I supposed to do now? I'm supposed to even bring them into my warehousing. So when I bring them into warehousing, my historical tables along with these particular tables will be useful for my analysis purpose. Okay, if I am trying to maintain the historical data for this particular table also, which is not having that particular usage, if I try to make this particular table, or if I try to construct the same table into my historical way as well, then what should I do? I should increase the memory, the capturing memory of this particular table. So unnecessarily I'll not be using this particular entire memory, but unnecessarily I'm wasting my resources of my database, which I don't want to. I want to optimize my database every time, right? So yes, I'll pull out the table as it is into my warehousing, whether, though it is not handling the historical data, because I'm happy with my current data, because that has got a reference to some of my other tables. Is that okay?
Yes.
All right, fine. So now, sorry guys. Where are we? Yeah, I'm talking about SCD2 now. Now once I complete the SCD2, you will understand the things, and once I complete the SCD3, you will get a better understanding on this. Right, SCD2 says that inserts are inserts and updates are inserts. So we'll take the same example again. Okay, I'll take the same example. I'll come up with the things. Okay, let's say this is my source and this is my target. Okay, so within my source, right, EMPID, primary key, ename, job, salary. Within my target, the columns that I have are in this way. SG underscore EMP. This is my primary key. Yes, Pravina, have you got any question? EMP number, ename, job, salary. Okay, then what I would say, I would go with another set of columns like record. Check your speakers, Pravina, if at all you're not able to hear me. Record insert date, and let me pull other columns as well. This, because everyone is able to hear me. Can you check your speakers, please? Alright, record updated date. I'll have these particular columns. Okay. You should be able to hear me now. Right, this is the data. I suggest you to check your speakers. Hey, thanks, man. Thanks, Swami. Alright. Alright, so employee ID, I'm taking it as 1001. Dutta, job is as QA lead, and salary is as 5,000. I have another record called as Satish, right, QA, and 2500. These are my records. Like earlier case, we need to have a job configured. The job responsibility is to check the incoming records, whether the incoming records are new or updated. So based on that, your data is going to get loaded. Right, now it is going to check this particular incoming records. Now I see them as my inserts. Alright, these are my insert records. Okay, these are my insertions. So what should happen? My data should get inserted into my target table. So I'm just inserting the data. 1001 Dutta QA lead, right, 5,000. Like earlier case, I am taking the data July 1st, and this would be as null. 1102 1001 Satish, sorry, QA 2500 0107 2015 and null. This is same because inserts are inserts. There is no change for inserts. Okay, let's say I have an update happening. Okay, I'm picking up only these two records to speed up the things. Okay, let's say I have an update happening. So the salary has been updated to 5,500. Okay, for the employee called as Durga. Now when this particular job is initiated, what this particular job will identify? This identifies that this particular record is an updated record and this is a no change record. Right, on what basis it is identifying? Okay, it checks for the employee ID in these particular tables. Yes, see the same employee ID. Okay, the mistake. This is 2. Okay, I'm sorry. This is 2. Okay, right. Now what is the employee ID here? 1001. Okay, I have 1001 in my target table. Now what it does? It checks for all the columns. Durga, QA lead, 5000, but it is as 5500. So it treats that, or it identifies this particular record as your updated record. Likewise, now I have Satish here. Okay, 1002, 1002. Satish, QA, 2500, 2500. So it identifies that this is a no change record. So it has identified one record as an updated record. Now what is the rule saying? Updates are seen as inserts. Okay. Now what are you supposed to do? You have to insert this particular record. So when I'm inserting, the surrogate ID value will be incremented by 1. I would include the same data called as 1001 Durga QA lead, right? Sorry, QA lead 5500, and let's say this was done on 10th of July 2015, and this value will be null, whereas the above value will be updated. Alright, this will be your 10th of 7th. Is that clear? Now am I maintaining my historical data here?
Yes.
Yeah, I'm maintaining my historical data. If for some reason next day Satish's salary is also changed and his designation changed, QA to senior QA, and this 2500 is changed to 3500, so what should happen? This is similar to 5500. So what it identifies? This is a no change record because it always picks the latest record based on the surrogate ID. It always checks for the latest record. According to the latest record, there is no change. 5500 is as 5500. So this would be a no change record. But this one, see here, Satish, but QA is changed to senior QA, and 2500 is changed to 3500. So it is an updated record. So what should happen here? It should be seen as insertions. So 11104 1002 Satish, right, QA senior QA, right, 3500, right. Let's say this has happened on 15th of July, and this will be null, whereas the above record says that the above record says 15th of July 2015. Simple. So what is happening here? Within the SCD2 type table, I'm able to maintain the complete historical data along with the current set of information. Is that clear?
Yes.
Alright. Now, these columns like record inserted date, record updated date, are these kind of columns are called as your audit columns. Likewise, you can also have columns such as flag and version. What this particular flag and version columns give? Flag, I mean, you can have, I'm not saying that they are mandatory. These will be mandatory. Insertion dates and updation dates are mandatory columns. Every warehouse will try to maintain, but the options goes according to the project. For the flag and version, few projects would try to have this particular audit columns included, few may not. So what this particular flag and version column give? The flag column will represent whether the data is new or old. Okay, very simple way of identification. If your record updated date is as null, then those records are your new set of records. This is a very simple identification. If your record updated date is null, that means they are new set of records. If your record updated date has got a value, then they are old records. Okay, so this particular flag column will clearly identify what are the new records that I have within this particular table, what are the old records that I have within this particular table. So this particular flag column would give me that particular conclusion over that particular data in that particular table. Likewise, I have the version column. So what do I mean by versioning? The number of times the data got changed, I would maintain a version. So let's say my version, initial version, I'm trying to maintain it as 1. So this will be my first version of data. These two records are my first version of data. But this is the second version of data related to Durga. And this is the second version of data that is related to Satish. If for some reason Durga is again changed, Durga's salary is again changed, so I'll be getting a salary of 6,300 or any change in designation. So what happens? This will be my third version of data corresponding to Durga. Likewise, if I have any new employee joining, let's say Kumar who has joined within this. Now what happens? The version would be, what would be the version? Let's say I have a Kumar who is joining us new in this particular source table. Right. This job has been loading the data, or this job is going to load that particular data into my warehouse. So what would be the version here? The version would be
1.
1. Perfect. Right. So what is version column doing? Version column is going to identify the number of times the data got changed. Flag is the column which will identify whether the record is new or old. So what will be the flag column for this? The flag column value would be new.
No.
Right. So what would be the flag column for this? For Durga 6,300?
With the new
It would be new. And this one should convert to old.
Old.
And the null value should be erased, and it should have the date on which this update has happened. Alright. So this is how your SCD2 type tables are implemented. Is that clear?
yes.
Yeah, clear, Durga.
Yes. Alright. Likewise, we have another set of classification. With that, I'll end for today. We'll talk about the rest things tomorrow. The next set of classification of tables are SCD3 tables.
Okay, in between one question, so in the
Please
previous
go
one,
ahead.
so for analysis, like what kind of data they would take, like which version they would take generally?
It all
Because
depends on the data, the number of times your data changed. Okay. See, every time for analysis, it is only your historical data that they take mainly, because your current is assessed by the history. If my performance needs to be assessed, then you have to ensure my previous data as well, right? If you want to take my classes, what you need the prior information. Okay, how is Durga delivering? Is he delivering the right content in the right manner, or he's up to the mark, or he's good, or he's poor, or he's worst? So your previous data will give along with the current data. Okay, let's say you have seen some of the reviews of Durga and you have attended today. So you may relate those particular reviews to the current situation that you are in, and then you may relate the things. Whether he is delivering the things in a good manner, or at least good, or bad, or worst. Okay, so for analysis, if the business is purely interested in talking about the historical data, then they would pick all the flag values as old and they would go with the analysis. If they are interested with both the things, then they would pick all the entire set of data. It totally depends on the business requirement. So we cannot directly say a requirement on the up ahead, like they will stress on this particular data. Okay.
okay, so in case we want to analyze the Durga's data in case, so this we have to take, there are 3 records updated so far. So
Yep.
we have to take those 3 and just compare what happens in start begin,
Yeah,
right?
what happens in start? So what is the hike that is
Yeah.
getting every year? What is the average hike that he is getting every year, if you need that? Or for how many number of years he is getting a promotion? What is the average duration that he is getting a promotion, or how many number of times he got promoted? Making sense? So you can figure out all the related analytical data on that particular table. Clear?
Okay, clear. Thanks.
Yeah, thank you so much. EMP number, primary key, key name, job, salary. These are my columns, the regular columns, boring columns. SG underscore EMP primary key, EMP number, E name. Now, when we are talking about SCD3 type table, the main thing that would come into picture is we have to identify the number of columns that are going to have a change in the source. Now, what are the columns that can go change in the source table? Will my employee number change if I'm sticking to the same organization?
No, it won't change.
Will my e-name change? Will my name change?
No, it won't change.
No. Will my job change if I'm sticking to the same organization?
No.
Yes. You will get
Yes.
a promotion,
I mean,
right?
sorry. Sorry, yeah, correct.
Right. Will my salary change?
Yeah, it
Yes.
obviously will change.
Of
Obviously.
course.
That is what we are for. Okay. Fine. Okay. So job. So I have figured out that job and salary are the columns which will go change. Okay. Now what am I going to do? See here. New underscore job, old underscore job. New underscore salary, old underscore salary. Likewise, I'll have my audit columns. I'm just leaving it there because you already have the information on that. Okay. Now this is how my target table will be constructed. Okay. Again, this is constructed by modeling team. Okay, when they have decided that this table will be in SCD3. Now let's talk about the same data again. Okay, 1001 Durga QA lead, 1002 Satish, right, QA, and 2500. Perfect. Now likewise I need a medium which is going to move the data from one system to another system. Okay, so it loads the data here. This job is responsible. It has figured out that incoming data is a new set of data because I don't see these particular records in my target table. So it will start loading. So how is the loading going to happen here? 1111101. Employee number is 1001. E name is Durga. Now into which job column do I need to load the data? Do I need to load the data into new job or old job?
Old job.
Why?
Because the designation or whatever the job is the current one. In case if you get promoted in future, you will have to update that in the new job. Just I'm thinking.
But do you have the same instance of data in your warehouse?
No.
I
It's the
don't have
first.
any instance. Let's say
Yeah.
Durga has joined as a QA lead in that particular organization. Can I say Durga lead QA lead as my old job?
No.
I
It's new
cannot,
one.
right?
Yeah.
So here, as I don't have this related data in my warehouse table, I cannot really classify this as my old data. I will always classify them as my new data because they are entering into my warehouse for the first time.
Okay.
They are entering into my warehouse table for the first time. So I'm classifying them as my new data and old will be null. I do not know what was his job previously. I'm just bothered about the current data that is going to get entered into my warehouse table. How he is entering into my warehouse table. What is his status? I don't see 1001 record in my table. So when I don't see that, I will always classify him as my new set of data. Likewise, new salary would be 5000. Old salary will be as null.
So
Likewise,
whenever the
another
data is entering into the target first time, so it should be considered as a new one.
perfect. Okay, null 2500 null. Okay, this is how the data got loaded. Let's take our situations again. Yes, 5,500. It got updated. Okay. Now when I execute this particular job, what happens? This job will determine that this is an updated record and this is a no change record, because these columns will always check for the new job columns and new salary columns. Okay, so I see new job column of Satish as QA and new salary column of Satish as 2,500. I can clearly say that they are no change records. Now the problem is with Durga. Okay, what happened here? Here there is a change in the salary, 5,500, but new salary says as 5,000. So the record got updated. So what happened earlier? Insert is happening as insert. Okay, but in case of your STD3, an update in source column, an update in one column of your source will update two columns of your target. So what would be the first update? First update would be old salary will be updated with new salary, and new salary will be updated with incoming salary. That means it is going to happen in this way. Old salary is going to get updated with new salary. It got updated. Likewise, incoming salary. So let's say I have a salary as 5,500 here. Okay, incoming salary. This is the 5,500 here. Incoming salary will be updated in this new salary column. Clear? So what is happening? Insert is happening as insert. There is no problem with it. Just leave it as it is. But with the update, an update in one source column, it has updated only one source column here. If an update is happening in one source column, then updates will happen in two different places in case of your target. The first update would be new underscore salary, sorry, old underscore salary will be updated with new underscore salary, and this new underscore salary will be updated with your incoming salary. Now for some reason, let's say Durga's salary was again changed to some 6,200. Let's say again this has got updated. Okay. Now what it identifies? This, when I execute this particular job, this job will identify that, okay, 6,200 is compared against 5,500 because it compares always with the new salary column. Okay, when a comparison is done, okay, it identifies that again this has updated. So what should happen now? The first update should happen in this way. The old salary should be updated with the new salary. Sorry. Old salary should be updated with new salary, and new salary should be updated in new salary column. Is that clear? Likewise, the same happens with your job and everything. So indirectly, what kind of a data are we maintaining in our warehouse table?
It is current only.
Current and recent history.
Previous. Recent history, yeah.
Right, not in the entire previous data. We are maintaining only current and recent history. Okay, so that is what these tables. Now SCD2 table is maintaining the complete historical data, whereas SCD3 is maintaining only current and recent history data. Okay, now if my business is not interested with maintaining the entire historical data, I am just happy to analyze my business with the recent data with a set of current data, then I would maintain my table with SCD3 process. I don't want to invest in maintaining my entire 10-year-old data in my table. I'm just happy with last 1 year data. So what would I do? I would go with SCD3 tables. I would not increase my database size. But the actual challenge will come when working with SCD3 tables would be when I have around 200 columns within my table. Of these 200 columns, if 100 columns are changing columns. Making sense? So what happens? My target table will have 300 plus columns, including the audit columns and everything. I'd have 300 plus columns. That means I'm increasing the size. Okay, this would be the challenge when working with the SCD3 tables. Okay, is that clear, guys? Everyone?
Yeah.
Yeah, it's clear.
Yeah. So what is happening in case of our SCD2? Inserts are inserts and updates.
Updates are inserts.
Oh, I already wrote, right? So I'll write in a different manner. Inserts happening in the source is seen as inserts in the target. Updates happening in the source is also seen as inserts. This maintains historical data, whereas this one, what says inserts are inserts and updates in one source column will update two columns of target table. Now what is this? Same thing. I'll just copy this. There is no change in it. Right. There is no change in it. But update in one source column will update two columns of target table. So what will be the two columns? What will be the update? Old column will be updated with the new column of target table. A new column of target table will be updated with the incoming data or source data. Incoming source data. Right. So what kind of a data is this going to maintain? This is going to maintain the current and recent history. Is that clear?
Yes.
Alright.
Yeah.
So what I'll do is I'll just give a break for today. Tomorrow we'll meet up again. We have only few more concepts. The concept would complete in another 45 minutes. Then I'll show you the actual testing one. So what are we supposed to do as part of our testing? So I'm going to pick a test file. I'm going to have some areas in between. Okay. And I have some transformations applied on that. So based on that, we'll try to derive a particular way to test a particular flow, or we'll try to derive one certain flow so that you can apply the flow on a project as a whole when you're working. Okay.
Okay, Durga.
Yeah. Thank you so much, guys. And you have to do me a help or a favor.